So welcome to the seventh session of this webinar series. Today we are scheduled with ducting and piping overview, that what exactly ducting is and what exactly piping is. As you can see in the image, it is this is the duct which is used to carry the air from one place to another place. What exactly duct? Duct is a conduit or passage through which the movement of air takes place, and this movement of air, it can be from outside, from outside to inside, or from inside to outside also. So that is your ducting. I will illustrate in brief that what exactly ducting is, what are the criteria that we need to consider during the duct design, and we will also see overview of piping, that what are the different pipings that we have chill water piping, we have refrigerant piping, we have drain piping. So all these are the different pipings, and how its designing is very much important. This is the image that you have seen here. This is just a plant room configuration, that how the plant room will look like, where there is chiller is there, cooling tower is there, pumps are there. So how the piping configuration will be done, and from there it will be your from there it will be your entire running of HV system, or that is basically your commissioning of HVAC system occurs. So that is what we'll be trying to I'll be trying to give you overview in today's session. So let's start with the today's session. So what exactly ducting? I'd not be using any PPT. I'd be using a writing pad for today's session. So what is ducting? It is a conduit of passage. It is a conduit or passage through which movement of air takes place. Through which movement of air takes place. So ducting is a conduit or passage through which the movement of air takes place. That is what ducting is called. Okay. So how it can be classified? How we can classify the ducting? So classification of ducting. Let us start with the classification of ducting. Classification of ducting. So the first one that we have, that is classification of ducting based upon manufacturing mode. मैन्युफैक्चरिंग मोड के ऊपर हम डक्टिंग को किस तरीके से क्लासिफाई करते हैं, and that is what we will be discussing here. So though we have just classified this into two types. The first one that we have, that is your factory fabricated and next one that we have, that is your hand fabricated or side fabricated. Hand / side fabricated. So what is the difference between these two? The difference between these two is that factory fabricated is something that it is manufactured with the help of machine. It is manufactured with the help of machine, with the help of machine, and it is manufactured by duct foreman at site. मतलब साइट के ऊपर, साइट पे जाके एक बंदा खुद से मैनुअली उसे कट करेगा, सीट को कट करके एंड सीट को बेंड करके दे जस्ट प्रोड्यूस द डक्टिंग. Okay, so this is the first classification of ducting. Now let us see here. I believe ducting you have seen, you have seen these type of things somewhere. So this is your ducting, this one. This one, these all things are ducting. With the help of air, with the help of this, the air distribution will be done, right? So this is the first classification. The first classification that we have, that is your factory fabricated those ducts which are being manufactured in the factory by the machine, and those ducts which are manufactured by duct foremen with the help of their hands, means that is with the help of their cutting tools at site. So that is your hand or site fabricated. Now let us move ahead and see the next classification that we have, that is your based upon, and B point, that is your based upon what? Velocity. So if you talk about velocity, we have number one, that is your low velocity, and number two, it is your high velocity. So this low velocity, that is what is the velocity of air that we are talking about? So it is used for comfort air conditioning. So this one used for comfort air conditioning, used for comfort air conditioning, and this one, it is used for industrial air conditioning. Industrial air conditioning. Okay, let's move ahead. Let's see the third classification. So the third classification that we have, that is your classification of ducting based upon classification of you can write like this, based upon what? Based upon nature of air it is carrying. Nature of air it is carrying. Now this one, it is very much interesting. Now you can find this, that suppose, let me draw one image and it would be much clear from there. Suppose this is your room. This is your room, and suppose this is your room and this is your AHU. AHU is what? That is your air handling unit, which is used to supply the air. Suppose this is your air handling unit, AHU, air handling unit. Air handling unit, that we call it as AHU. ठीक है. So what exactly happens here? So we need to supply the cold air from where? We need to supply the cold air from this AQ to this one. It is your room. So this is your room. So this is just the 2D drawing that I am showing you right now. So what exactly happens here? Suppose this is your duct. Okay, so this is your air hand. This is your HU and this is your room. And here, with the help of this one, it is your diffuser. Okay, and now let's move ahead and see here. This is again and then it will be your so these are the four classification. What exactly? This is something that we need. Let me write, then it will be much better. This is your SAD, that is your supply air duct. This is your RAD, that is your return air duct. This is your EAD, that is your exhaust air duct. And this is your FAD, that is your fresh air duct. Okay, and let me show you the arrow also. So it is going in this direction. Air is coming in this direction. Here the air is going from here to here. Some part it is going in downward and some part it is going here, and it is going outside. Here it is your fresh air duct. It is taking fresh air from here to and entering inside the AHU. So what exactly this is? This is your diffuser. This is your diffuser, return air diffuser. So this is your return air diffuser. So what exactly happens here कि यहाँ से cold air supply हो रहा है and it is taking the return air back from here. So basically there are four types of duct based upon the nature of air. It is if it is carrying air from your indoor unit to room, so it will be your SAD, that is your supply air duct. This is your supply air diffuser. Supply air diffuser. Yes. Sir, where we mount the AHU floor, handle or ceiling. AHU air handling unit, it can be ceiling suspended also, it can be floor mounted also. So both the things are possible. This is just a schematic drawing where it is being shown that how exactly it is being that is basically the working principle that I am showing you right now. It can be ceiling suspended, you can hang it from the ceiling also, and you can place it on the floor also. Okay, so let me write, that is SAD, that is your supply air duct. Supply air duct. What is the function of this SAD? It will carry air from your indoor unit, that is your AHU, to room. So air movement, it will be from AHU to room. Now next one, it is your RAD, that is your return air duct. It carries air from room to your indoor unit. Return air duct. Return air duct. It carries air from room to your indoor unit. Okay, I will explain, Mr. Siri. Okay, let me complete this drawing first. So EAD is what? That is your exhaust air duct. So it takes the air from either from indoor unit or from room to outside. So that is your exhaust air duct. Exhaust air duct. And last one, it is your FAD, that is your fresh air duct. Fresh air duct. So what is the function of this? It will carry air from outside to your indoor unit. Okay, so there is one query from Mr. Chakres, that what is the work of diffuser? So the air which is coming from this air handling unit with the help of supply air duct, it will be the air that is being carried from this AHU to room. It will be supplied inside the room with the help of this diffuser. Diffuser का काम क्या होगा? ये जो air इस supply air duct में आ रहा है, इस air को diffuse करके room के अंदर discharge कर देना. That is the work of this diffuser, because it can't be thrown directly. So diffuser is something that will spread that air inside the room. So that is basically the work of this diffuser. Okay, is this clear to everyone? This is one of the important fact that you will see, you will observe in any of the industry, that how this supply, return, fresh air and exhaust air duct. So it can be the four types of ducting that I have shown you here. It includes in one cycle. It can be in different also. Suppose if we are using any exhaust system, so there we'll be using only exhaust air duct. Suppose we are taking air from outside and we are supplying it somewhere, so that is only fresh air duct. So it can be only one system at a time, or it can be all the system at a time. Both the things are possible. Let's move ahead and see. That is your fourth classification. That is your classification of ducting. Ducting based upon network distribution. Why some part of RAD is fed back into the AHU? Is fed back into the AHU. Okay, there is one query, that why some part of Mr. Tikeshwar Sahu has just asked one query, that why some part of RAD is fed back into the AHU. देखिए, I will share one more link today in this description box. That is the working of this cycle. That how this cycle will work. See, suppose what happened. We are supplying cold air from this machine to this particular room. So once that air reaches this room, we people, once we exhale, this air becomes uneasy, this air becomes unhealthy due to the development of microbial organism. So what we did, we supply. So there is always a pattern like this. We will observe a pattern like this, that is cold air being supplied here and it is being taken back as a return air. So why we are taking it as a return? Because we want to filter that air, so that filtration provision, it is there in AHU. So that filtration provision is there. So since this air become unhealthy, so that's why we filtered this air, and that filtration it is being done in the AHU. So we have just taken this air, the excessive air that we are having with, because of the addition of this fresh air, we are doing the exhaust of that, and this air which is being taken as a return, because this air, it is at a lower temperature. Suppose this is 24 degrees Celsius supplying, and this is the return air which is going at, it will be 28 or 29 due to friction. So in that case, what happened? In that case, from 29 to 24, it is easier to convert as compared to from 45 to 24. and that is why this air it is being used continuously, so that there is a energy conservation is there. I believe, Mr. Takeshwar, it is clear to you. I will also share one link of your all air system. You just go through that video. That is one of the very important video of an entire plant room, that how exactly it will be done. And you can I will just try to share the link of that particular video in the description box, so that you can go through that. So in today's video you would be having that the video link in the description. Okay, let's move ahead and see the classification of ducting based upon what? Based upon network distribution. Based upon network डिस्ट्रीब्यूशन के बेसिस पे हम किस तरीके से क्लासिफाई करेंगे. नंबर 1, that is your main duct. And number 2, it is your branch duct. So there is first one that we have, that is the main duct. And next one that we have, that is the branch duct. So in main duct, what is there? Suppose this is your main duct is there, and from that there is one more piece which is being assigned like this. So this is basically your branch duct. Okay, so this one, it is your main duct, and this one, it is your branch duct. Okay, let's see the last classification that we have. Classification of ducting based upon pressure. Classification of ducting based upon pressure. So in that we have low pressure, next one we have medium pressure, after that we can have high pressure. So in low pressure it will be up to 3/4 inch of water column. It can resist up to a pressure of 3/4 inch of water column. In water column we are measuring this pressure, and it will be from 3/4 to 6/4 inch of water column, and from 6/4 to 12/4 inch of water column. Sorry, it will be 9/4 inch of water column. So generally this is used for comfort air conditioning. This one, it is used for comfort air conditioning, used for for comfort air conditioning, and these two things are used for industrial air conditioning. Industrial air conditioning. Okay, so this is just a basic classification that what we have for the ducting. Let's move ahead. What are the steps involved in duct design? So steps involved in duct designing involved there is one query that some of the students don't have a Telegram account, so please share a request to create a WhatsApp group for us. So it's very difficult to create a WhatsApp group because we have so many candidates are there. So WhatsApp Telegram link anyone can share in this group, and you can join the Telegram. You can create your account because in Telegram it is very convenient for each and everyone. So steps involved in duct design. So what are the steps involved in duct design? Yes, so that is the link. You can use that particular link and you can okay. So the first thing that we have, that is your amount of cold or hot air that needs to be supplied from where we will get. Now I want some answers from your side, that is how much amount of cold air or hot air. Suppose if you are doing it for summer, that cooling it will be done with the help of air, and suppose if you are doing in winter, then it will be your hot air. So how it will be done? Right, so it will be, we will get this value from where? That is the amount of cold air and hot air from the heat load calculation. Right, HU it is a unit, but actually the value of that air we will get it from the heat load calculation. So from heat load calculation, so from there we will get this value. So that is the first thing. So in order to proceed for the duct designing, we need to check this value, first. Accordingly the duct designing will be started. That is the first step of this. Second step, it is your selection and location of indoor unit. Selection and location of indoor unit. Selection and location of indoor unit. So how exactly it will be done? Let me explain what are the types of indoor unit it can be. Indoor unit क्या क्या हो सकता है? No, it cannot be wall mounted. See, as of now, अभी जो हम discuss कर रहे हैं ducting से related discuss कर रहे हैं ना. So the indoor unit, it can be those units where the ducting is possible. वैसे unit ही हो सकते हैं यहाँ पे. So the option, it will be your either AHU, air handling unit, first one. It can be your FCU, that is basically your false fan coil unit. Then it can be your ductable split AC. Ductable split AC. This we have discussed in classification of air conditioning. Ductable split ACs. Then we have an option of what? Ductable split AC. Then we have an option of package AC, that we call it as rooftop unit. So these are the options that we can have. What इंडोर यूनिट implies? इंडोर यूनिट बेसिकली मैं यहाँ पे जो पूछना चाह रहा हूँ, ये पूछना चाह रहा हूँ कि इंडोर यूनिट क्या हो सकता है। तो इंडोर यूनिट अगर आप डक्टिंग के कंटेक्स्ट में डिस्कस करें तो वैसे ही इंडोर यूनिट हो सकता है जिसके माउथ के ऊपर डक्ट को कनेक्ट है, जैसे वॉल माउंटेड है। सो इट इज नॉट पॉसिबल टू कनेक्ट द डक्ट इन द वॉल माउंटेड यूनिट, सो इट कैन नॉट बी डिस्कस्ड है। वो यूनिट वैसे यूनिट्स है, यूनिटरी प्रोडक्ट्स है जो डायरेक्टली वहीं से एयर को सप्लाई कर देगा, दैट इज फ्रॉम द यूनिट इटसेल्फ। नाउ इन केस ऑफ those units where जहाँ पे we need to supply the air with the help of a duct, so that is basically उस यूनिट्स के बारे में हम लोग यहाँ पे डिस्कस करें। सो इट कैन बी योर AHU, इट कैन बी योर FCU, इट कैन बी योर डक्टेबल स्प्लिट AC, इट कैन बी योर पैकेज AC। यू जस्ट सी द वीडियो ऑफ बाइफर्केशन ऑफ डायरेक्ट रेफ्रिजरेशन, क्लासिफिकेशन ऑफ एयर कंडीशनिंग जो हमने डिस्कस किया है, आप उस वीडियो को देखें। फ्रॉम देयर इट विल बी मच मोर क्लियर। Let's move ahead. Once we that is the selection that you decide from these three units, and then its location is also important. So let me first of all I will write this and then I will explain it with the help of drawing also, then it will be much more clear. After that, once the location it will be done, selection and location of indoor units, then selection and location of air terminal, selection and location of air terminals. एयर टर्मिनल्स का सिलेक्शन भी करना है एंड लोकेशन भी डिसाइड करना है, वेयर एग्जैक्टली वी हैव टू AHU, it is not an outdoor unit. AHU, it is your indoor unit. Air handling unit, it is an indoor unit. Outdoor unit, AHU will be connected with chiller. So chiller is our outdoor unit. Okay. AHU, air handling unit, it is not an outdoor unit. It is a indoor unit from where the cold air it is being supplied. There is one query from Mr. Gaurav, is that AHU it is an outdoor unit. So it is not an outdoor unit, it is an indoor unit, because those units which will supply the air, so that will be treated as an indoor unit. अगर wall mounted unit को हम indoor unit कहते हैं, so why it is? Because it is kept inside the room. So see, in a similar way, AHU can also be kept inside a room, and that's why it is treated as an indoor unit. Its outdoor unit, it will be either condensing unit or it will be chiller. Selection location of air terminal. So few options are there where there is grid ceiling, where there is grid ceiling. So here will be diffuser is preferred, and where there is gypsum board ceiling, there it will be your grills will be preferred. So this is your preference. So this is your preference. Let me explain कि grid ceiling क्या होता है. एक बार मैं आपको शो करूंगा कुछ इमेजेस, then it will be much more clear. The device by which you are connecting, it is showing a Gaurav, so that's why I am addressing you with a Gaurav. Okay. Okay, so let me show you what is grid ceiling and what is diffuser, what is gypsum board ceiling. See here, this is basically your this type of ceiling. I believe you have seen this type of ceiling, and this is basically your grid ceiling. So these are all your grids, the square box. These are all grids, and this is your diffuser. So the diffusers are placed in that, and that is basically your grid ceiling. I believe this type of ceilings that you have seen here also, it is in the same way, where diffusers, your fire sprinklers and lighting, all these are decided, smoke detectors. So all these are fitted in this. Okay. So this is basically your grid ceiling. So in case of grid ceiling, diffusers are preferred. Now gypsum board ceiling, let me show you gypsum board. Gypsum board ceiling. So you can see here. So this is basically a gypsum board ceiling, and see here. So this is gypsum board ceiling, where there is false ceiling, and where suppose here it is your lighting is there, you can use grills here also. I can show you some images where you can see grills also. So इसी में हम क्या कर सकते हैं, यहाँ पे ग्रिल्स वगैरह लगा सकते हैं, and that is where ग्रिल्स आर प्रिफर्ड, जहाँ पे हम देखते हैं ग्रिल्स को प्रिफर करते हैं. ठीक है. So these false ceilings are your use. So जहाँ पे gypsum board ceiling है, there we would be using grills for the air distribution. Air को supply करने के लिए grills वहाँ पे use करते हैं. Then move to the fourth point. आपने क्या कर लिया, selection कर लिया कि आपको ग्रिल लगाना है, ग्रिल्स यूज करना है या डिफ्यूजर्स यूज करना है. देन आफ्टर दैट वी वुड बी सिलेक्शन करने के बाद उसके लोकेशंस को भी फिट कर लिया. देन वी विल डू द नंबरिंग ऑफ, वी विल डू सिंगल लाइन डायग्राम, प्रिपरेशन ऑफ सिंगल single line diagram, that we call it as SLD. हम लोग SLD प्रिपेयर करेंगे, सिंगल लाइन डायग्राम के थ्रू प्रिपेयर करेंगे. Fourth point that we have, a fifth point that we have, that is your numbering of network develop. Numbering of network develop. जो भी नेटवर्क बना है, डेवलप हुआ, उससे हम यूज करेंगे. both the ceilings are almost same, but grid ceiling में क्या होता है, it will be for the entire ceiling, पूरे ceiling को. But gypsum board ceiling में क्या होता है, it would be using only some part of the ceiling. numbering of network developed, then selection of shape and size, selection of duct shape and size. डक्ट का शेप और साइज दोनों हम लोग सेलेक्ट करेंगे. इसके लिए क्या है, फॉर डक्ट शेप it is your, it can be your round, it can be your rectangular or square also, or it can be your oval, or we call it as flat oval. फ्लैट ओवल. ठीक है. साइज के केस में क्या कर सकते हैं हम लोग, फॉर डक्ट साइजिंग 3 मेथड्स आर यूज्ड. 3 मेथड है जो हम लोग यूज करते हैं डक्ट साइजिंग के लिए. दैट इज योर 3 मेथड्स. Number 1, that is your velocity reduction method. Velocity reduction method. Next one, it is your equal friction method. And third one, it is your static regain method. Static regain method. ये 3 मेथड्स है जो आप डक्ट के शेप और साइज के लिए यूज करते हैं. लेट्स मूव टू द 7th पॉइंट. जब आपके पास शेप और साइज आ गया, right, grid ceilings are used in metros, metro stations. So 7th number, so duct length, from where we will get the duct length. So here, from here we will get the duct length, and from here we will get the duct width and height. Okay, let's move to the 7th point. So once we decide the different shape and shape selection, it will be based upon the cost, because rectangular and round duct, rectangular and square ducts are cheaper as compared to round duct, and flat oval duct, it is one of the costliest one. Okay, so based upon that, we will just do with a double line diagram. So that is basically a 2D representation of the ducting. 2D representation of the ducting, that is your that is basically your double line diagram. Point number 8, it is your selection and location of controlling devices. Selection and location of controlling devices, it is your VCD, that we call it as volume control damper. Then it will be your collar damper. Then it can be your fire damper. It can be your fire damper. So कहाँ पे ये लगाना, जहाँ पे network distribution होगा, there it is mandatory, because how come it know that के 400 CFM that we have to take in this direction and 800 CFM we have to take in this direction. So for that we have to use this one. 9th number, that is your So once this is done, then we will do the noise level calculation. Noise level calculation. 10th number, total surface area calculation. Surface area calculation and number of seats required. How much seats are required? Total surface area calculation. Will we do practical on these 9 points? How to do? Definitely, we can just calculate the noise level. There is one formula also. With the help of that, we can calculate the formula to calculate this. It is your 10 plus 50 log V base 10 plus 10 log. This is your log A base 10. If you put velocity in meter per second and A it is in square meter. It is velocity of air and A it is your cross-sectional area of duct. Cross-sectional area of duct. Area of duct. ठीक है. Total surface area calculation and number of seats required. After that, we will do the total static pressure calculation. Total static pressure calculation. It will be your internal static. Internal plus external. Based upon that, we will do the HU selection. Based upon that, indoor unit selection. Indoor unit selected. Indoor unit selection based upon static pressure. After that, we will do the gauge selection. Gauge selection is something that is thickness of sheet. Thickness of sheet used in ducting. डक्टिंग में जो सीट यूज होगा उसकी थिकनेस को हम लोग देखेंगे. एंड फाइनली वी विल डू विद द BOQ, that is bill of quantity of ducting and accessories. Ducting and its accessories. ठीक है, that is bill of quantity. कौन सा प्रोडक्ट यूज हो रहा है और उसकी क्या क्वांटिटी है. VCD, कॉलर डैम्पर, फायर डैम्पर, व्हाट एग्जैक्टली दीज आर. ये सारी चीजें क्या होती है अभी आपको क्लियर हो जाता है. एक ड्राइंग के ऊपर डिस्कस करते हैं, देन इट विल बी मच मोर क्लियर. फॉर एग्जांपल, देयर इज वन एरिया, वन रूम इज लाइक दिस. एंड एक रूम में इस तरीके से ये आपको फॉल सीलिंग का प्लान दिख रहा है. एंड फॉल सीलिंग प्लान अगर इस तरीके से है, सो व्हाट इज दिस, विच टाइप ऑफ सीलिंग इट इज दिस, बताए. गो टू कमेंट बॉक्स एंड रिवर्ट मी विच टाइप ऑफ फॉल सीलिंग इज दिस. ग्रिड, राइट. सो दिस इज योर ग्रिड सीलिंग. आपको ये ग्रिड्स के फॉर्म में दिख रहा है. सो दिस इज योर ओके. क्विकली एक बार ग्रिड्स बना लेता हूँ। ठीक है, सो इन ए सिमिलर वे ये आपका ग्रिड सीलिंग हो गया, दिस इज योर ग्रिड सीलिंग एंड वंस वी so this is your grid ceiling, huh? This is your false ceiling plan. And that is basically your grid ceiling. अब एक एक पॉइंट को देखते हैं और उसको रिजॉल्व करते हैं। यहाँ पे जो मैंने लिखा, सबसे पहले select amount of points. So for example, after doing the heat load calculation, we got this value, that is the capacity of your AHU. It will be your, so suppose this is your AHU. So that is quantity. It is suppose quantity after doing the heat load calculation we came to know it is 4000 CFM. Selection and location. Selection we have did with the AHU, and location we location we have decided. So after that, based upon the type of ceiling, we will decide the diffusers. So this is the location. This is, since this is a grid ceiling, then we will go with what? We will go with diffusers. So suppose we are using diffusers like this. How many diffusers we will use? So that you will select in the you will study in the diffuser part, at how many diffusers will be used. As of now, I'm just giving you an outline that how it can be done. आपने एक सिमेट्री को ऑब्जर्व करते हुए डिफ्यूजर्स फिट कर लिया यहाँ पे। सो ऑल दीज आर व्हाट? दीज आर द सप्लाई डिफ्यूजर। मैं अभी सिर्फ और सिर्फ सप्लाई पे आपको शो करके बता रहा हूँ। दीज ऑल आर द सप्लाई डिफ्यूजर्स। So this you have did. Now preparation of SLD, you have to do a single line diagram. So let's try to connect this with one line, and that is basically your single line diagram. You just try to do like this. And this is basically your network development. So single line diagram, it is done. Preparation of single line diagram. Then numbering of network developed. Numbering of network developed. So we will do numbering from here: 1, 2, 3, 4, 5. This one it is your 6, 7, 8, 9, 10, 11, 12, 12 and 13. So your 1, 1, 2, 3, 4 or 5. This is your main duct, and rest are branch duct. Is this clear? Rest are branch duct. Okay. Today I'm not feeling well, so there might be some, my voice is very a bit low because I'm not well today. So this is your preparation of single line diagram and numbering of the entire system. So this one, it is done. Up to point number 5, it is done. Now let's see selection of duct shape and size. How its shape and size it will be. Suppose for example, we are going with rectangular duct. So, and with the help of these three methods, any one of the method, we came to know the size also. So we will convert this line into double line diagram. After that, once we got it, so it is your DLD, that is your double line diagram. So we will convert this into double line diagram. So let me convert this into double line diagram. So length, you can get it from here to here, it is the length. So how it will be your, so this is your double line diagram. So this is basically your double line diagram, as you can observe here. So this is basically your ducting 2D drawing. 3D drawing, it will be visible only on Revit software. Okay, so this is basically your 2D drawing. This one, it is your AHU, air handling unit, AHU. Now after that, what we will do? Controlling devices. How come it will know that from here how much air will be supplied in this direction and how much? So for that we will just produce one controlling devices. यहाँ पे हम एक fire damper लगाएंगे. Fire damper at the very initial stage. So fire damper, it is always marked in red color. So this is your fire damper. So at the very initial we will write this one. This is your fire damper. And after that जो हम use करेंगे, it will be your VCD, that is your volume control damper. तो एक VCD यहाँ पे लगेगा, एक VCD यहाँ लगेगा, and उसी तरीके से एक VCD यहाँ पे लगेगा, one VCD. So all these are your VCD, volume control damper, so that it can decide that how much air. So quantity of air, it will be decided by this VCD. So these all are VCDs. So I will write here this as VCD, that is your volume control damper. Right, because the quantity of air is decreasing and Q equal to the formula continuity equation, it is there, Q equal to A into V. There is one query that why we are continuously reducing the duct size, because Q equal to A into V and Q is reducing, and so definitely we have to reduce the cross sectional area. So once the area is also reducing, so your this duct size reduces. Fire damper, why it is fire damper it is placed because suppose there is motor is there and there might be a chances that it can catch fire and this fire can transmit inside the room. So in order to reduce, in order to obstruct that, fire damper is used. And what they will do, they will just restrict the fire. ये fire को restrict कर देगा. Okay, so up to this point that we have discussed, now after that all these are calculations that we will do. So this is just an overview of all the things that you have to do in the duct designing part. Let's move ahead and see the very small discussion on the piping part, that what exactly chill water piping is and how it can be done. So I will explain it with the help of the help of what? With the help of one schematic drawing. If you have any queries up to this point, you can ask. Meantime, I'm opening one file of AutoCAD file. So just give me 1 minute time. The file is opening, so just give me 2 to 3 minutes time so that it can be opened. All these things, there is one query that after branch duct, how much distance? So diffuser to diffuser distance, branch to branch. So there is a long discussion on that. Okay, so it requires some time to discuss that. But since you have asked that after branch duct, how much distance we usually at least 600 to 800 distance must be there, so that there should not be any hindrance in that. Right, let me show you on my screen. Let's start with the piping part. As you can see here, this is your chill water piping schematic is there. So here, let us start from here. So this is your chiller, this is your air cooled chiller. After that, these two are two numbers of air cooled chiller is there. And now with the help of that, what exactly? So in basically in chilled water piping, what are the things that we'll be doing? We'll be doing first one, it is your pipe dia calculation. Second one that we'll be doing, let me write here so that you can understand also. The first one that we'll be doing here, it is your chilled water piping. So pipe dia calculation, that is the first task. Next one that we will be doing, that is your frictional losses or head losses. After that, your pump selection. So these are the major tasks that we will be doing in chill water piping. Right, so let us see, this is your chiller. From chiller, these are the pipes. So pipe dia calculation, how much dia it will be there, so that we will see it with the help of chart and with the help of software also. So this is your chill water line, and you can see here the nomenclature also. So your orange color line, it is what? Orange color, it is your chill water supply line. This is your chill water return line. So as you can see here, so this is your chill water supply line, orange color line. So its dia, it will be 125. So that selection, it will be done with the help of chart or software. So this dia, after going through that, it is coming here. So two pumps are used, that is basically your secondary pump. So secondary pump, it will be used where? It will be used between chiller and your air distribution unit, that is your either AHU or FCU. So Here it is your gate valve, Y strainer, and pressure gauge is there. So these two pumps are used. Once they are combined, then again this water it is carrying. Now here it is being supplied to different AHUs. AHU 1 is there of 11,000 CFM, 2 11,000 CFM, third one it is 10,000, 10,000, and 10,000. So it has supplied air in this. Everywhere the dia and flow rate it is written. Flow rate it is in gallon per minute. It is in gallon per minute. So everywhere it is, it's dia and gallon per minute it is written. So here it is 67667 GPM, and here it is going only 312. So इन सब का समेशन जो होगा ये इधर जा रहा है, और इससे ऊपर जो हम लेके चले गए दूसरे फ्लोर के ऊपर, यहाँ पे भी मल्टीपल AHUs आते हैं. So here also we are using multiple AHUs. हर AHU में in the supply line Y strainer and gate valve will be there, and balancing valve ये रिटर्न में आएगा. रिटर्न लाइन अभी डिस्कस करेंगे. So इधर से ये सारे AHUs और FCUs में कनेक्ट हो गए. Here it is used for, at the last it is 40 TR, there is additional load is there, and that is set for the future expansion. अगर फ्यूचर में वो बिल्डिंग एक्सपेंड होगी तो इट कैन बी यूज देयर. यहाँ से एक रिटर्न लाइन लिया जो ब्लू कलर में डॉटेड है. सबसे रिटर्न लेते हुए जितना फ्लो रेट सप्लाई जा रहा है उतना ही फ्लो रेट नीचे रिटर्न आएगा. इससे कंबाइन करते हुए इस इधर पे भी कुछ रिटर्न सप्लाई आया है. इससे कंबाइन करते हुए यू हैव जस्ट टेकन है ये ब्लू कलर का लाइन. यहाँ पे आपने 3 पंप्स आर यूज, एंड दीज आर योर प्राइमरी पंप्स व्हिच कनेक्ट्स योर AHU और FCU टू चिलर. जो AHU FCU को चिलर से कनेक्ट करता है. पंप के सक्शन में हमेशा वाई स्टेनर लगता है. देयर विल बी अ वाई स्टेनर एट द पंप सेक्शन. सो वाटर इज कमिंग फ्रॉम हेयर टू हेयर. सो वाई स्टेनर इज यूज्ड. यहाँ पे यहाँ वाई स्टेनर लगा था क्योंकि वाटर इज गोइंग फ्रॉम हेयर टू हेयर. सो पंप के सेक्शन में वाई स्टेनर, और पंप के डिस्चार्ज में चेक वाल्व है. हेयर इट इज योर चेक वाल्व. पंप के डिस्चार्ज में यहाँ पे, पंप के डिस्चार्ज में यहाँ पे चेक वाल्व है. सो ये आ गया. ये दोनों लाइन को, तीनों लाइन को कंबाइन किया. कंबाइन करते हुए इसे चिलर्स में कनेक्ट कर दिया. एंड दिस इज योर बाईपास लाइन विच कनेक्ट्स योर bypass line which connects your return, and this is your return line and this is your supply line. इन दोनों लाइन को कनेक्ट करते हुए ये कर दिया. So basically इसके अंदर हमें what we have to do, we have to do the chill water pipe dia selection. That is done with the help of a pipe sizer, microwave pipe sizer. और और दूसरी चीज क्या है, it can be done with the help of a there is one chart with, from there we can do that. Okay, so this is just a very in short, it is brief of your chill water piping. And let's meet tomorrow with the detail description के किस तरीके से डक्टिंग को डिजाइन करते हैं कैड के ऊपर. अभी कैड के ऊपर हमने नहीं देखा, और किस तरीके से पाइपिंग को करते हैं. एंड आफ्टर दैट वी वुड बी सीइंग इसी चीज को 3D व्यू में हम किस तरीके से देखेंगे. दैट कम्स अंडर द मॉडलिंग पार्ट. दैट इज अ पार्ट ऑफ द बीम. दैट इज योर बीम बिल्डिंग इंफॉर्मेशन मॉडलिंग है, उसके अंदर हम लोग देखेंगे. ओके, so let's stop here for today. If you have any query, you can ask your queries. One thing that would be providing you in today's, that is your link in the description box for all air system. All air system के बारे में आपको description box में we will provide you so that you can just go through that. Average of a salary of any HVAC engineer, it will starts from at least 15 to 20,000, and it can go up to anywhere, because in India the persons people are taking a huge salary in this HVAC profile. So minimum salary that you can get, it is from 15 to 20,000 per month, considering the this COVID scenario also. Okay, and in this COVID scenario also there is a huge demand of medical equipments and medicines. So many manufacturing plants are being pharmaceutical companies are being set up. और वहां पे हमें air conditioning की huge requirement है, because there is mass production of vaccine and all these medicines, medical equipments. So वहां पे and COVID centers are being also being established. तो हर जगह पे air conditioning is required. So even in COVID scenario also there is a huge job opportunities in this field. So why chiller system is more popular over VRF system? See, you can ask all these queries uh, in the last session that will be concluding. So there it will be much more beneficial. आप अपने सारे चीजों को note down करके रखें, and then you can ask your queries in the last session that will be having tomorrow and day after tomorrow. Tomorrow we'll be having a session on duct designing and pipe designing on AutoCAD, that how we can do that, how we can do the drawings, and then okay, okay, thank you. We will explain you what we will provide you in the assignment. Don't worry for that. Okay, thank you.